Hi, in this video we're going to look at linear equations and we will solve them. That is, to find the solution set. So first off, what is a linear equation? Well, we're going to be dealing with linear equations of one variable for right now, and it's an equation that can be put in the form ax plus b equals 0, where a is not 0, and a and b are real numbers. So this is the form, ax plus b equals 0. The way we solve linear equations is by using this property of equivalent equations. And equivalent equations are equations with the same solution set. And so typically in the way that we do things in algebra, we take an equation and then we manipulate it in certain ways by getting a sequence of equivalent equations, each one getting simpler and simpler until we can just read off what the variable value should be in the solution set. Okay, one set of equivalent equations is given by this, we'll just call it a theorem. So if we have two expressions, say a and b, these are just expressions, so you could have like two expressions here, that could be a and that could be b. And we have a real number, just call it c. We can take that c and add it to both sides, so a plus c, b plus c. This equation will have the same solution set as a equals b. So that means we can take an equation and add the same number to both sides, or perhaps subtract the same number from both sides, and that resulting equation will have the same solution set as the previous one. Very useful. We can also multiply both sides of an equation by a number c, and that will also have the same solution set as long as c is non-zero. So we can multiply both sides of an equation by a number. This also allows us to divide, because we can always think of division as multiplying by a reciprocal. So if we wanted to say divide both sides by 2 here, we would think of the c as being 1/2. Right? Okay, so these are the main operations that we use to find a solution set. We use just this one equivalent equation after another, each one getting simpler. So adding, subtracting, multiplying, and dividing. So not dealing with 0. Okay, here's a couple of equations. These are linear equations. They don't quite have this form, but you can see that the powers of the variable here, in this case it's x, is only the power of 1. So this could be put in this form. We're not going to try to put it in this form, though. Our goal is to get x equals something, some number, and that will be the solution to this equation. Okay, so let's look at this, and we can see that there are a bunch of x's throughout this equation, and we need to get x equals something. So that means we need to take all of these x's, get them all together on one side, and everything else on the other. That will be the goal here. All right, so I'm reading this equation. Let's see, 5 times the quantity 2x minus 1 equals 3 times the quantity 1 minus x plus 5x. I see there are x's that are inside parentheses. We can't combine them if they're inside the parentheses. We cannot move them. We cannot use this property while they're inside parentheses. So we need to break them out. And to do that, we'll distribute. So we'll take this 5 into this difference. 5 times 2x is 10x. 5 times negative 1 is negative 5, equals 3 times 1 is 3. 3 times negative x is negative 3x. And then we have the plus 5x. All right. So we've taken the 5 and distributed it, the 3 and distributed it, and now we have terms with x that can be moved around or combined. In this case, we've got a negative 3x plus 5x. So I'm going to leave the left-hand side alone. So 10x minus 5 equals 3. And then we take negative 3x plus 5. That leaves us with 2x. Okay. Now, I'd like to get everything, all the x's on one side. Let's move them all to the left-hand side, and everything without an x to the right-hand side. So I will use this property. I'm going to add, well, in this case, we're going to subtract the same thing from both sides. I'm going to subtract 2x both sides, and I will also subtract the 3. Actually, I'm going to add the 5. So the subtraction of the 2x gets the 2x out of the right-hand side. It's all the x's out of the right-hand side. And then adding the 5 will move the constant to the other side. Okay. So 10x minus 2x is 8x. Negative 5 plus 5 is 0. Okay. Equals 3 plus 5 is 8. And then 2x minus 2x is 0. All right. So we're left with 8x equals 8. And now we can use this property, multiply both sides by the same number. In this case, we're going to divide both sides by the same number. Divide by 8. That gives us that x equals 8 over 8, which is 1. 8 divided by 8 is 1. All right. And so our solution, x equals 1, and the solution set would be just the set containing 1. It might also be a good idea at this point to take this x and plug it back into the original and see that it does verify that. Let's just do that very quickly. So x equals 1. So start up here. You've got 2 times 1, it's 2, minus 1, which is 1, times 5 is 5. Okay, so this left-hand side is 5. Right-hand side, we get 1 minus 1, which is 0. 0 times 3 is 0. Plus 5 times 1, which is 5. So 5 plus 0 is 5. So 5 equals 5. Indeed, that is a solution. All right, and it is, then the solution set will be the set containing 1. All right. If you're following along, why don't you pause the video and try the second example. And then, well, we'll work it. Okay. So the first thing that you might have seen is that we have kind of the same thing we had up here. We've got a y that's trapped inside this parentheses, and we can break it out by distributing. So the left-hand side is 3y plus 5 equals 3y plus 9. And then minus 4. So we get 3y plus 5 equals 3y plus 5. All right, if you notice we have the same thing on both sides, we could subtract the 3y, I guess. You can also subtract the 5. In this case, you get 5 equals 5, which, if you recall from the previous video, this is an identity. This is a true statement. That means the original was an identity. And what is an identity? Well, identity is true for all replacements of the variable. So if we're asked to find the solution set, as in the set of all x values that make the equation true, and all, or in this case the y values, we're to find all the replacements of the variables that make this equation true, we need to list all of them. Also, they're all solutions. So the entire real number line. So negative infinity to infinity. You could also say all real numbers. Okay. So we have we've gone over the definition of linear equations. We talked about equivalent equations and the methods we use to find the solution set. And here's a couple of examples. One that has a solution. So this was a conditional, right? And this has all real numbers as solutions. Those are identities. Okay. So we'll look at a couple more examples.